Hi guys, welcome back to Java Programming. This is episode 25 in which we are going to talk about multi-threading. These are the contents which we'll cover today. Introduction to multi-threading, thread lifecycle, thread priorities, create a thread by implementing a runnable interface, create a thread by extending a thread class, and thread methods. So let's start. Introduction to multi-threading. Java is a multi-threaded programming language, which means we can develop multi-threaded program using Java. A multi-threaded program contains two or more parts that can run concurrently, and each part can handle a different task at the same time, making optimal use of the available resources, especially when your computer has multiple CPUs or cores. By definition, multitasking is when multiple processes share common processing resources, such as a CPU. Multi-threading extends the idea of multitasking into applications where you subdivide specific operations within a single application into individual threads. Each of the threads can run in parallel. The OS divides processing time not only among different applications, but also among each thread within an application. Multi-threaded programming enables you to write in a way where multiple activities can proceed concurrently in the same program. Thread lifecycle. There are 5 states in the thread lifecycle, so let's look at each one of them one by one. New state. A new thread begins its life cycle in the new state. It remains in the state until the program starts the thread. It is also referred to as a born thread. Runnable state. After a newly born thread is started, the thread becomes runnable. A thread in this state is considered to be executing its task. The waiting state. Sometimes the thread transitions to the waiting state while the thread waits for another thread to perform a task. A thread transitions back to the enable state only when another thread signals the waiting thread to continue executing. Timed waiting state. A runnable thread can enter the timed waiting state for a specified interval of time. A thread in the state transitions back to the runnable state when that time interval expires or when the event it is waiting for occurs. The terminated or dead state. A runnable thread enters the terminated state when it completes its task or otherwise terminates. Thread priorities. Every Java thread has a priority that helps the operating system determine the order in which threads are scheduled. Java thread priorities are in the range between min priority, a constant of 1, and max priority, a constant of 10. By default, every thread is given priority norm priority, which is a constant of 5. Threads with higher priority are more important to a program and should be allocated processor time before low priority threads. However, thread priorities cannot guarantee the order in which threads execute and are very much platform dependent. Create a thread by implementing a runnable interface. If your class is intended to be extended as a thread, then you can achieve this by implementing a runnable interface. You'll need to follow 3 basic steps. Step 1. You need to implement a run method provided by a runnable interface. This method provides an entry point for the thread and you'll put your complete business logic inside this method. Following is a simple syntax of the run method, public void run. Step 2. You'll instantiate a thread object using the following constructor. So this is the constructor. It takes 2 parameters, the thread name and the runnable object. Where thread object is an instance of a class that implements the runnable interface and thread name is the name given to the new thread. Once a thread object is created, you can start it by calling start method, which executes a call to run method. Following is a simple syntax of start method, void start. Now let's see a program that creates a new thread and starts running it. My runnable method, which implements runnable, I have my constructor, I have my run method, which it has to override since it's implementing runnable interface. I put some statements into it. Then I have my start method. Finally, I have a test thread class which has the main method. I create 2 instances of my runnable demo class and I start them. This is the output which I get. Please note that you might get a different output because of your processor or OS. Create a thread by extending a thread class. The second way to create a thread is to create a new class that extends thread class using the following 2 simple steps. This approach provides more flexibility in handling multiple threads created using available methods in thread class. So there are 2 steps. In the first step, you need to override run method available in the thread class. This method provides an entry point for the thread and you'll put your complete business logic inside this method. So this is the syntax, public void run. In step 2, you start it You start the object by calling start method, which executes a call to run method. Following is a simple syntax of start method, void start. Now here's an example in which we are going to extend the thread class. So this is the same program which we already saw for runnable interface, only it's extending thread class instead of implementing a runnable interface. Rest all things remain the same. And in the main method, the way we call our threads is a bit different, because here we are extending thread class. So we create two instances of thread demo. We specify the thread names, and finally we invoke the start method on the threads. This is the sample output which we get. Again, your output might be a little different because of your OS and processor. Now thread methods. Public void start starts the thread in a separate path of execution, then invokes the run method on this thread object. Public void run. If this thread object was instantiating using a separate runnable target, the run method is invoked on that runnable object. The setName method, which takes the string parameter, changes the name of the thread object. There's also a getName method for retrieving the name. Then setPriority method, which takes an integer parameter. It sets the priority of this thread object. The possible values are between 1 and 10. 1 and 10 are both inclusive. SetDaemon method, which takes a boolean parameter. A parameter of true denotes this thread as a daemon thread. The join method, which takes a long parameter. The current thread invokes this method on a second thread, causing the current thread to block until the second thread terminates or the specified number of milliseconds passes. The interrupt method interrupts this thread, causing it to continue execution if it was blocked for any reason. Is the alive method returns true if the thread is alive, which is any time after the thread has been started but before it runs to completion. Now the previous methods are invoked on a particular thread object, but the following methods in the thread class are static. Invoking one of the static methods perform the operation on the currently running thread. The yield method causes the currently running thread to yield to any other threads of the same priority that are waiting to be scheduled. The sleep method, which takes a long parameter, causes the currently running thread to block for at least the specified number of milliseconds. Holds lock method, which takes an object parameter, returns true if the current thread holds the lock on the given object. Then we have current thread method, which returns a reference to this currently running thread, which is the thread that invokes this method. Then we have dump stack method, which prints the stack trace for the currently running thread, which is useful when debugging a multi-threaded application. Okay, now this is a sample program which makes uses of various thread methods and various thread concepts which we covered in this session. So what I suggest you to do is you can pause this video. There are 3 files: displaymessage.java, guessanumber.java, and threadclassdemo.java. So I suggest you to pause this video, try these programs out in your IDE, Eclipse or NetBeans or whichever we are using, and run the program, watch and analyze the output, and then move on. So 3 classes, these 2 classes, and this is the 3rd class, in which we have the main method in which we perform all the operations. Okay guys, this was it for this episode. Thanks for watching and please subscribe. See you in the next episode.